Okay, let's go ahead and continue talking about chapter 11. Today we're going to talk about common functional groups. So if you have that sheet from chapter 11 from before, you can use that. Oh, and we're also going to talk about chemical structures. So a normal chemical structure looks like this. This is like a regular Lewis structure that we have been drawing. We draw all of the bonds between all the atoms, and we also draw any lone pairs that we might have. Okay? That's really time consuming. So something that we can do is we can draw the condensed structure. So these are the same structures. We have a methyl group. That's what we talked about last time. We have a methylene group. We have a methyl group. Here's a hydroxyl group and a methyl group. And so instead of drawing all the bonds, we're gonna do this like shorthand. We have no lone pair. We have a bond, and then we have a methyl group. So we're just showing the pieces. Okay. So you need to recognize that these are the same. Even though the lone pair is not shown, even though the bonds are not shown, they're still there. They're still satisfying the octet. So make sure that you can go between those. So I have an activity. Oh, that's the answers. I have an activity for you, and I made extra. They're kind of short. So go ahead and see if you can match the normal and the condensed structures. You don't have to mix them up. So take a minute to match the normal structure to the condensed structure. So there's pairs. You're supposed to find the pairs. Alright, you already got it?
So when we played, yeah, so and like
I'm going to give you another minute, and then I'll pull the answers up on the board, and you can look.
this one's I
The highest was 96. And the median was
'Alright. Let's up here. So this is the answers. So is your question any left? So like this one has a triple bond, so I better have a triple bond. This one has an oxygen, between two carbons and one carbon, so that better match. Okay, we have two different double bonds. One has two carbons and a double bond. This one has a double bond and then two carbons. So I have three carbons on the center. Okay, so that's pretty straightforward. You're just like, it's called a condensed structure, you're condensing it. I can't remember if it's this chapter, but sometimes it will ask you, and we'll talk about, next time we'll talk about skeletal structures. Sometimes it asks you to do the skeletal structure, and sometimes it asks you to do the condensed structure. So you need to know the difference, and you need to pay attention to the instructions, to the question, and make sure that you are drawing the correct structure. I think there's one of the tests, I can't remember which one it is. It will let you draw the wrong type. So make sure that you read. This is condensed. If it's asking for the condensed structure, make sure you're drawing something. Okay, one of the topics in Alex is going to ask you to identify the different bonds in a condensed structure. So for example, even though this CH is here, this methylene group, this is not, it's not methylene. Anyways, we have a carbon-hydrogen bond here, but really what's happening is this carbon is bonding to this carbon. And so you have to take that out from a condensed structure. So look at this molecule for a minute, see if you can figure out how many carbon-to-carbon bonds, how many carbon-to-hydrogen bonds we have, how many carbon-to-oxygen bonds, and then see if you can figure out how many lone pairs. Even though they're not drawn, they're still there. So see in this condensed structure, see if you can count those. Okay, let's go over this. How many carbon-to-carbon bonds are there? Carbon to carbon. There are two. There's one here, and then there's one here. So this hydrogen is this hydrogen should really get here. So carbon to hydrogen, this is actually carbon to carbon. There's two of those. How about carbon to hydrogen? And now I hear on it. I think there are three. So we've got one here, carbon hydrogen, and then carbon hydrogen, two of those. So 2 plus 1 plus 3. Okay, this is a single bond. We're saying carbon to oxygen, just a single bond. How many are there? 2. There's one here. One here. This is a double bond. I would call that one. So there's 2. And then, how many lone pairs? So they're not shown, but they're still there. How many does oxygen need?
2.
Yep, so each oxygen has 2, even though it's not shown.
6.
So that's 6. And then, nitrogen also has a lone pair. So there's 7 lone pairs. Okay, alright. Okay, the next part is about functional groups. There's a whole bunch of functional groups. So luckily, you don't have to know all of these. You just have to know, I don't know my paper. You just have to know the ones on your review or your note sheet. Okay? So you either have to memorize the functional groups or you have to write them on your note card. Okay? Those are the only ones you're responsible for. Depending on what you're doing in chemistry, or what your job is, you would maybe learn more of these. There's a whole bunch, so you are only responsible for these. Okay. Maybe we will go through them, and we'll just talk through, make sure we can identify them. Carboxylic acid. So remember, our group is just whatever. So this group group is connected to some kind of organic molecule. And what we're looking for in a carboxylic acid is you have a carbon, and the carbon is connected to both a hydroxyl group, an OH group, and it's also connected to a double bond O. So it has a carbonyl and a hydroxy group. That is a carboxylic acid. The next one here is an ester group. So what we're looking at it for in an ester group is a carbon connected to both an oxygen and a double bonded to an oxygen. Okay? And this oxygen is connected inside of our long carbon chain. Okay, so we have carbon connected to an oxygen, connected to something else, and the carbon is also connected to oxygen. That's called an ester. I call this an amide bond. We have carbon connected to nitrogen, and also double bonded to an oxygen. Okay, so that's what we're looking for an amide bond. An aldehyde is a carbon connected to a double bonded oxygen, and then the carbon chain ends at an aldehyde because we have a hydrogen at the end. So this one has to be some kind of end. A ketone is a carbon connected to a double bonded oxygen, and then it doesn't have anything special around it, so it's just going to have other carbons around it. Ketone. An alcohol group, so this is the same thing as a hydroxyl group. So it depends on the question if you're looking for an alcohol, OH, or a hydroxy group. This is not an alcohol group because it has that other piece. Because you have to distinguish, is it an alcohol? Is there nothing connected to it? Or is it's also connected to a carbon double bonded to an oxygen? That would be different. An ether group is some oxygen in the middle of a carbon chain. There's nothing else special about it. If it has a carbon double bonded to an oxygen, that's an ester group. So an ether group is just an oxygen in the middle. And then the last one, let's turn this off, is the amine group, where we have a nitrogen connected to some carbon chains, or it could be connected to two hydrogens on the carbon chain. So this is an amine group. An amine is different than an amide because the amide has this carbon double bonded to oxygen. If it doesn't have that, then it's an amine. Okay, so those are the functional groups we need to know. Now we're going to practice some in Alex. And I opened it, hopefully it's still great. Still logged in. I'm still here. Okay, let's see which ones. Not that one. Let's see. Condensed, interpreting condensed, this is the first thing we talked about. Interpreting a condensed chemical structure. So this is, we're looking at the condensed structure, and we remember there's still lone pairs and there's still bonds between the carbons here. We just have to count. So the first one says number of carbon to carbon single bonds. So we're looking through this chain. So here's one, and then this carbon is actually connected to this carbon. Okay. The hydrogen can only make one bond, it's bonded to the carbon. So 1 carbon-carbon bond, 2 carbon-carbon bonds, 3 carbon-carbon bonds. This one says number of carbon-hydrogen single bonds. Okay, so I'm just going to look for anything that's carbon-hydrogen. No, there's one. 1 carbon-carbon, carbon-hydrogen bond, and then carbon to hydrogen, there's 2 more here. So that's 3. This one says number of oxygen to hydrogen single bonds. Carbon to oxygen single bond. 1, 2, 3. These are oxygen, carbon to oxygen double bonds, so that doesn't count. And then number of lone pairs. We don't have any nitrogens. Those have 1. Oxygen has 2. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 7, 8, 9, 10. I see 10 lone pairs on this. Check. Okay. Let's do another one. So this one we're looking for carbon to carbon bond. So this carbon is bonded to this carbon. If I drew out the Lewis structure, this is the condensed structure, and that's how they draw a condensed structure. So this would be 2 carbon to carbon bonds. Number of carbon-hydrogen single bonds. Okay, we've got carbon to hydrogen 3 times here, 2 times here, that's 5. And then number of nitrogen-hydrogen single bonds. Oh, there's nitrogen connected to 2 hydrogens, so that's 2. And then number of lone pairs, nitrogen gets 1 lone pair. So you have to know what the Lewis structure is looking like, but this is also helpful to know the bond pattern. So like nitrogen forms 3 bonds and has 1 lone pair. Carbon has 4 bonds and no lone pairs. And hydrogen has 1 bond. Oh, which one do we miss?
There's only one.
Oh, 1 carbon to carbon. I counted the carbons. I didn't count the bonds. Okay. All right. Okay, let's do another one. This one says number of carbon to carbon single bonds. We've got 1 here. Carbon to carbon. Oops. Number of carbon to hydrogen single bonds. We've got 3, 4. Number of oxygen to hydrogen single bonds. So there's 1 here, 1 here. So that's 2. And then number of lone pairs. We have 2 oxygens. Each oxygen has 2, so that's 4. And there's no nitrogen and no halogens. Okay, how are you guys on that one? Feel okay? Okay. All right, next one is, let's see, what else we talked about? We didn't talk about skeletal structures. We'll leave that for next time. So now we're going to draw a skeletal structure. We'll wait till next time on skeletal. Functional groups. So this one is, we're just identifying. So it gives us an example. You don't get credit for the example on the test. This is just to tell you, okay, this one, we're looking at this OH group. All right, this one, we have carbon connected to a nitrogen, and then connected to a carbon. So usually we're looking at the heteroatoms. What's the pattern in the heteroatom? That means look for something that's not carbon and hydrogen. So we got nitrogen. And then we have 2 functional groups that have nitrogen. We have an amide and we have an amine. The amide has to have a carbon double bonded to oxygen right next to the nitrogen. The amine doesn't. So our example just has nitrogen connected to carbons or hydrogen. So this one's an amine. Okay, this one, if you see a double bond between 2 carbons, they're trying to trick you. So don't look at the double bond if it's just between carbons. Okay, there's no functional groups that are, for us, in our examples, that have to do with carbon double bonded to carbon. Okay, so ignore that. They're trying to distract you. So I see a double bond carbon, and then I see a hydrogen. So this is on the end. If you see carbon double bond to oxygen right next to the end, right next to a hydrogen, that's going to be an aldehyde. So carbon double bond to oxygen right at the end of the molecule is an aldehyde. You have to spell these right too, so make sure you spell them right. Okay, and then the last one. Okay, I see carbon double bonded to oxygen, and it's right next to an oxygen. So that's going to be an ester group. Carbon double bonded to oxygen right next to an oxygen. And doesn't have to be on the right side. It can be on the left side. The oxygen could be on the left side. So this is called an ester group. So this one's just a practice. You're just getting familiar with these new terms. All right, this one we have an oxygen in the middle. And there's nothing else special, so that's going to be this one, the ether group. This one, we have a carbon double bonded to oxygen, and the other heteroatom here is nitrogen. So that's right next to the ketone, so that's going to be this amide bond. Oh. Or amide. I say amide. I think it might be amide. Okay, the last one, on this sheet. This one's kind of tricky because of the way they drew it, but I see this carbon. It's connected to a double bonded oxygen. The other heteroatom that's not carbon or hydrogen is this oxygen, which is an OH.
So if we have carbon double bonded to oxygen and and single bonded to OH, that's going to be a carboxylic acid. Okay. All right, questions on that one? I think you can do that with just matching. All right. We have lots of time. Do you want to stop there, or we could go over the next day? I have split this in the past into 3 days. You just want to have some work time? Okay, all right, sounds good. We'll go over skeletal structures on Friday.
Yeah.